the use of a separator is to bring the electrodes very close together, so to decrease the resistance of the battery. In this case, the separator can be a porous propylene sheet. The conductivity is in the order of millisiemens, which is enough for making a battery operating. As we will see that this is the liquid are the most popular common electrolytes, but in the future trends indicate that we can also move to polymers. Now this is a very rude photograph, but it gives you an idea. How can we make the battery? Well, graphite as well as lithium cobalt oxide is the powder, is a compound. So to make a battery, we have to, in some way, to change this powder into some morphology which is used for the battery. So what we do, we take you want to tell us what we do to make an electrode? Since you do that, right? Yeah. So, can you tell? Be my substitute. No? You don't want? Okay. I just ask him because I know that most of you know this very well, but just for the few of not aware of that. So we mix the active material, where the active material can be graphite or lithium cobalt oxide, plus some carbon powder, because we want to increase the electronic conductivity, and we can use that like this, with SP stands for super P, it is a very high conducting carbon, plus a binder. What is a binder? It is a kind of, this is a carbon, this is a conductive component. B is the binder, which is a polymer. Most commonly PVDS, polyvinylidene fluoride. We take, all these are solid, of course. So we take a low boiling solvent, maybe tetrahydrofluorine, okay? And we make then a slurry, this solvent plus all this solid, and then this slurry is deposited on a current collector, which is aluminum in case of cathode, and copper in case of anode, and then the solvent is evaporated off. So we will have a film formation, which is, you can see here, you can see in the back the copper current collector, and this then is a film of a graphite with a binder and carbon. And this is the same thing. We have an aluminum current collector, and we have on here we will have a slurry of lithium cobalt oxide, graphite and binder, so we have a film. So one question here is why for the cathode we use aluminum and for the anode we use copper. Remember that one important aspect of this battery, especially for production, is the cost. And aluminum costs much less than copper. Anybody can give me the answer? Come on, DJ, you know the answer. Be my substitute. Or maybe maybe not you. Maybe this time Kim Yoon-gong can tell me, right? Why we are using? We have to use copper at the anode, and we cannot use aluminum. It would be much better to use aluminum. No? Don't you think? Yeah, so we cannot use, actually, we cannot use aluminum here because lithium does alloy with aluminum. So we have to use something which is not reactive with lithium. Good. So we can go on. This is also a very bad pictures, but give you an idea. Oh, I forgot. And in between, of course, there is the separator, which is this porous polypropylene felt. And then you see what we do, we put these strips of anode and cathode with, of course, the current collectors are outside. So suppose this is the current collector of the anode, copper. Then here we have the anode film. Okay. And here we have the current collector with aluminum. And here we have the cathode. So this is the cathode, this is the anode. And in the middle, there is the separator, okay? So we can put these three parts together and then wind all this wide, because in this way we will have, I don't know if I have a picture here. Yes, in this way we will have a lot of material which can be then housed in a very small volume, like for instance this cylindrical cell. So we have all this winded together. Then we will put electrolyte from here in order the electrolyte is absorbed in a separator. Then the battery is closed. Actually sealed to avoid contact from the from the external air. And of course this is just a scheme, but now there are automatic machines which are able to produce this morphology continuously. And here you have some examples. I think you have also one here in this lab. So you can, with this machine, produce, you see, first maybe produce the anode, the cathode, and the separator. They wind them together and form a large number of batteries. There are many of these machinery now. So what are the types of lithium batteries that we have? The most common is the here I have a Japanese example. I took it from internet. So the most common is the one having graphite as anode, LiPF6 mixed organic carbon as electrolyte, and lithium cobalt oxide as the cathode. And this can be prepared in cylindrical form or in prismatic form like this one. And this is now the most of your cellular phone have this type of cell. Then there are what they are so-called push cell, where the chemistry of the anode and the cathode are the same, apart from some small difference. but where the liquid organic electrolyte has been replaced by a gel type of electrolyte. We will discuss that in the future, but although these batteries are called lithium-ion polymer, they are actually not really solvent-free, because this gel electrolyte contains some liquid. And then instead, at the end, excuse me, the future trends are instead batteries which are totally solvent-free. We call lithium polymer batteries, and these have usually, again, they go back with the old idea of having lithium metal anode. We will see why. And then a polymer electrolyte that is not containing any liquid, and another type of cathode. So you see this battery, in this battery, all the chemistry has been renewed: anode, cathode, and polymer. Okay, so we will see again how the battery this battery works. Here you see again the separator. Here is the positive, which is the lithium cobalt oxide, and this is the negative, which is the graphite. The red dots are lithium ion, and the black is carbon. The carbon is graphite, and this is oxygen and transition metal. So this can be CO2, for instance. Okay. So in charge, you see, we will have the corner which goes in the upper part. It's not supposed to be here. So this is the external charge. When your cellular phone is at the end, you plug in the phone, and this is the and your cellular phone has a plug-in wire. I mean, which is because the plug-in, when you plug in, you have a kind of alternate current. So your cord, when you charge the telephone, includes